In this problem, two charges are separated by a certain distance. A third charge is placed in the middle between those two charges. What is the net force acting on that middle charge? So in my problem here, I have a positive 32. I'm going to call that charge 1, and a negative 10.13 microcoulombs. Call that charge 2. So we have this positive charge 1, and on the other side over here, this negative charge 2. And then we're going to put this charge number 3 right in between the two of them. So we have a positive charge number 3. And we want to know the net force on this charge 3. Well, charge 1 is going to repel charge 3 because opposites are going to repel one another. So this is the force on number 3 because of number 1. And then charge number 2 is going to attract number 3. It's going to be a smaller force because charge 2 has a smaller charge, but this will be the force on number 3 by number 2. And so we need to find those two separate forces, and now we see that they're in the same direction. So the net force on number 3 is going to be that force created by number 1 plus that force exerted by number 2. And so again, we need to find these two forces, then we can add those together to give us the net force. They both go to the right, so we're going to treat those both as being positive values. And so what this means is we need to use Coulomb's law two separate times. We need to find what is the force on number 3 because of number 1. And so Coulomb's law is Coulomb's constant times charge 3 times charge 1 divided by the distance squared. And so let's go back to this distance again. We said in the beginning that charge 1 and charge 3 were 16 centimeters apart. So from charge 1 to charge 3, did I say that right? Charge 1 and charge 2 are 16 centimeters apart. So between number 1 and number 3, if we placed it right in the middle, we have an 8 centimeter distance. And of course, we're really going to want that to be measured in meters. So 0.08 meters is going to be our distance. We'll also notice these charges are measured in microcoulombs. So as I go to plug them in here, I'm going to convert those to coulombs. But we'll take our Coulomb's constant, and I have rounded that. Sometimes we use 8.988 times 10 to the 9. I rounded this one, just going to use 9 times 10 to the 9 Newton meters per Coulomb squared times charge 3. It's 5.07 times 10 to the negative 6 coulombs. And again, that micro, I let it become 10 to the negative 6 coulombs. Times charge 1 is 32.2 microcoulombs, so it also becomes 10 to the negative 6 coulombs. And we're going to divide that by the distance squared, 0.08 meters squared. All right, so I'm going to find this value. 9 times 10 to the 9 times 5.07, 10 to the negative 6 times 32.2 times 10 to the negative 6. All of that divided by 0.08 squared. And so we get a force of 229.6 newtons. All right, so that's not our answer. That's just the first thing we needed to find. Now we need to do that same process to find what's the force between charge 3 and charge 2. So we want to use Coulomb's law again. I'm not going to write it all out again, but this time we're going to use charge 3 and charge 2. We're still going to have our 9 times 10 to the 9 Newton meters squared per Coulomb squared. Those coulombs, by the way, those are canceling. The meters are going to square and cancel, and I forgot to write meters squared right there. But we end up with newtons like we want. So charge number 3 again, 5.07 times 10 to the negative 6 coulombs times charge 2. And right here, it doesn't matter that charge 2 is negative. I'm still going to write a 10.13 times 10 to the negative 6 coulombs. The negative, I already used the negative to tell me what direction this charge was going in. Right now, I'm just trying to find the magnitude of this force. And it's the same distance, 0.08 meters. And we're going to square that. So I'm going to go back in and just recall what I had just a moment ago. And only difference now is we have 10.13 instead of the 32.2 that we had the first time. And that gives me a force of 72.2 newtons. And so now I know these two forces, and like we said here, we want to get the total force, we want to add those together. So this net force is my 229.6 plus the 72.2. So 229.6 plus 72.2. Get a total here, I'm going to say 301.8 or 302 newtons going toward the right, or going toward charge number 2.